let's start the chapter number 1, Similarity. At the end of this chapter, you will be able to understand ratio of area of two triangles, basic proportionality theorem, converse of basic proportionality theorem, tests of similarities of triangle, property of an angle bisector of a triangle, property of areas of similar triangles, and the last module is the ratio of the intercept made on the transversal by three parallel lines. Introduction. In the previous standard, we had already studied ratio and proportion. In this chapter, we will use it in order to relate areas of two triangles. Before going to our first module, that is ratio of area of two triangles, let's understand the significance of ratio and proportion. In the given diagram, we observe two boys, boy A and boy B. The height of boy A is 180 centimeter, whereas height of boy B is 120 centimeter. Now, how do we relate both of them? How does they differ from each other? The answer is by using ratio of their heights. Hence, if we take ratio of height of boy A to height of boy B, then we can write 180 centimeter upon 120 centimeter, which will give 3 by 2. Therefore, length of boy A or height of boy A is equal to 3 by 2 times length of boy B or height of boy B. This means that boy A is 1.5 times taller than boy B. Here we relate two objects in terms of their heights. In this way, we can relate any fundamental property of an object like length, area, volume, density, mass, etc. In this module, we are going to study the relation between areas of two triangles and their properties. Now let's do one activity, finding the heights of a given triangle. Consider an equilateral triangle, triangle x, y, z, such that if we take vertex x and draw a line perpendicular to base yz, similarly, if we take vertex y and draw a perpendicular line to the base xz, also if we take vertex z and draw a perpendicular line to the base xy and give the name P, R and Q, then by drawing the perpendicular from the vertex to the side opposite to it, we get the height of the triangle. The triangle has three sides, that is bases, and three vertices. It also has three heights. In this given activity, we got three heights or corresponding three bases. For base yz, height is xp. For base xz, height is yr, and for base xy, height is zq. If we consider a scalar triangle, triangle ABC, then for base AC, height is PR. See this, for base AC, our height is BR. The BR is the perpendicular drawn from the vertex B to the side AC. So here we are considering side AC as a base and height is BR. Again, for base AB, see this is the side AB which can be considered as a base, and by taking vertex C, And drawing the perpendicular from C to AB, we got CS as a height. So for base AB, height is CS. Similarly, for base BC, height is AT. For base BC, your height is AT. Now, if you take isosceles triangle, triangle POS, then for base PO, height is SAF. For base SO, height is PY. And for base PS, height is OW. Model number 1, ratio of areas of two triangles. Let's find the ratio of areas of triangle ABC and triangle PQR. Here we observe triangle ABC, in which BC is the base and AD is the height. Also, triangle PQR having QR is the base and PS is the height. Therefore, area of triangle ABC to area of triangle PQR is equal to 1 half into BC into AD upon 1 half into QR into PS. Therefore, area of triangle ABC upon area of triangle PQR is equal to BC into AD upon QR into PS. Here we are cancelling 1 half and 1 half from numerator and denominator. Hence, the ratio of area of two triangles is equal to the ratio of the product of their bases and corresponding heights. See this, here BC and QR are the bases for these two triangles and AD and PS are the heights. If we consider the base of a triangle is B1 and height is H1 and the base of another triangle is B2 and height is H2, then the ratio of area of these two triangles can be written as B1 into H1 upon B2 into H2. If we apply some condition on these two triangles, the condition 1, if the height of both the triangles are equal, then let's take two triangles once again, triangle ABC and triangle PQR. If you observe carefully, the height can be represented by H, symbol H, is same for both these triangles. Therefore, AD and PS are equal. Therefore, area of triangle ABC upon area of triangle PQR is equal to BC into H upon QR into H, which is equal to BC upon QR, as H and H will get cancelled. Therefore, area of triangle ABC upon area of triangle PQR is equal to B1 upon B2, as BC is the base of triangle 1 and QR is the base of triangle 2. From this condition, we obtain one property. The ratio of the areas of two triangles with equal heights is equal to the ratio of their corresponding bases. Let's come to the condition 2. If the bases of both the triangles are equal, then observe the figure carefully. The figure says that triangle ABC and triangle ABP. In this figure, AB is common base for both these triangles, but heights are different. Hence, they are represented by H1 and H2. Therefore, area of triangle ABC upon area of triangle PQR is equal to AB into H1 upon AB into H2. But AB and AB are the common base, hence they will get cancelled And what we get? H1 upon H2. So our final answer is H1 upon H2. From this activity, from this condition 2, we get the property, the ratio of the area of two triangles with equal heights is equal to the ratio of their corresponding bases. Now let's do one activity. Activity first. In the first activity, it is observed that the triangle ABC itself contains triangle APQ such that AR is the height for triangle ABC as well as triangle APQ. In order to find area of triangle ABC to area of triangle APQ, we have to take the product of their bases and the corresponding heights. But in this problem, height for both these two triangles is same, which is AR. So we can write BC into AR upon PQ into AR and cancel out AR, and the final answer will be BC upon PQ. In the second activity, we will observe the figure. Triangle LMN and triangle DMN are having common base, which is MN, but their heights LP and DQ are distinct. Therefore, area of triangle LMN upon area of triangle DMN is equal to MN into LP upon MN into DQ. As Mn is the common base, it will get cancelled from numerator and denominator, and the final answer will be Lp upon dq. In third activity, they are asking M is the midpoint of the segment AB and segment CM is the median of triangle ABC. Then area of triangle AMC upon area of triangle BMC is equal to what? Now, what is meant by median? A median of a triangle is a line segment joining a vertex to the midpoint of the opposite side. See this. In the given triangle, triangle ABC, CM is the median. From vertex C, if you draw a line which bisect the side AB into two equal parts, then the CM will be considered as median. So they have already given segment CM is the median, and because of that we got AM is equal to BM. Okay, so let's come to the problem. Area of triangle AMC upon area of triangle BMC. What is that? First of all, base of triangle AMC is AM and the height is CN. Now see, this green color line is the height of triangle. It is not a median. Don't get confused yourself. This is CN. CN is the height of the triangle. Such kind of activity we have already done in the beginning of this lecture. So AM into CN, and for triangle BMC, the base is BM and height is again CN. So this particular triangle is the case of equal height. So we can cancel the heights Cn and Cn from both this numerator and denominator. And the final answer will be Am upon Bm. But in the given median, Cm is the median which bisects side AB into Am and Bm. As Am and Bm are equal, this ratio will be 1. This is the answer of this activity. Let's solve the solved examples. Example 1. In the adjoining figure, A is perpendicular to BC, segment DF is perpendicular to line BC, A is equal to 4, DF is equal to 6. Then find area of triangle ABC to area of triangle DBC. Here we have to find the ratios of areas of triangle ABC and triangle DBC. Okay, so let's write those two triangles. Area of triangle ABC upon area of triangle DBC is equal to, here in triangle ABC, BC is the base and A is the height. So write down this BC, which is a base, into AE as a height, upon triangle DBC. BC is the base again and DF is the height. So BC into DF. In the next step, we will cancel this BC and write simply AE upon DF. Therefore, as AA is equal to 4 and DF is equal to 6, which is already given, so substituting the value, our final answer will be area of triangle ABC upon area of triangle DBC is equal to 2 by 3, which is the reduced form of 4 by 6. This is our answer. Example 2. In triangle ABC, point D on the side BC is such that DC is equal to 6, BC is equal to 15. Find area of triangle ABD to area of triangle ABC and area of triangle ABD to area of triangle ADC. So here triangle ABC and triangle ABD, these are the two triangles, okay, the bigger one and a smaller one. In these two triangles, AP is the height, which is a common for both, but AD is the base for triangle ABD and BC is the base for triangle ABC. So let's solve one by one. Solution. Let's take this ratio first. So area of triangle ABD upon area of triangle ABC is equal to BD into AP. BD is base, AP is height, upon BC into AP. Again, BC is base, AP is height. As AP is a common height for both these triangles, we will get cancelled. The final answer will be BD upon BC. The reason for this is triangles having equal heights. Okay. So BD upon BC, we have few values where BC is equal to 15 and DC is equal to 6, but we don't know what is BD. So in order to get BD, we can write the equation BC is equal to BD plus DC. As DC is equal to 6 and BC, entire BC is equal to 15. So 15 is equal to BD plus 6. Therefore, finally, BD is equal to 15 minus 6. Therefore, BD is equal to 9. We can substitute this 9 over here So finally we left with 9 upon 50. This is the answer of first ratio of two triangles. The second is area of triangle ABD upon area of triangle ADC is equal to, now the triangles have changed, A, B, D and A, D, this one, A, D, C. So in triangle ABD, BD is the base. So BD into AP, as AP is the height, just like previous one. And in triangle ADC, DC is the base and AP is the height. We have already learned such kind of things in our previous modules. So DC is the base into AP as the height. As AP are same, we will cancel, and finally BD upon DC will be our final ratio. The reason for this is triangles having equal heights. Therefore, now we will have BD is equal to 9 and DC is equal to 6. So 9 by 6 is equal to 3 by 2. 3 3s are 9, 3 2s are 6. So this 9 by 15 and 3 by 2, these are the answer. So we can further solve this 9 by 6 into the reduced form. 3 3s are 9 and 3 5s are 15. So 3 by 5 is the final answer. In the next question, example 3, quadrilateral ABCD is a parallelogram. P is any point on side PC. Find two pairs of a triangle with equal areas. So from the given figure, we have to find pair of triangles having equal areas. So how to find it? If we want to find pairs, such pairs, the condition must be their bases and heights are same. It means if two triangles having same height and same base, then both of the triangle will have equal area. Let's write this. Solution. If two triangles both have equal height and equal base, then they have equal area. Therefore, if you take triangle ABP and triangle DBP, let's write first pair, triangle ABP and triangle DBP. Then area of triangle ABP upon area of triangle DBP is equal to, as we see, BP is the base, and if we name this point as a M, then DM is the height for both of these triangle. As ABCD is a parallelogram, so AD and BC are parallel to each other. It means the distance between AD and BC is same. Hence, DM is the distance between them, which is a perpendicular, and we can consider this as a height for these two triangles. Okay, so BP into DM, which is base into height for triangle ABP, and for triangle DBC, we will have again BP into DM. So this pair of triangles will satisfy this condition in which we have equal height and equal base. So our final answer is 1. It means area of triangle ABP is equal to area of triangle DBP. This is our first pair. In the second pair, we can take triangle APD and triangle ACD. Look at this yellow region, these two triangles. APD, yellow plus this white one and plus this orange one. So this is the entire triangle. And ACD, again yellow, white and orange one. So let's write this first. Triangle APD and triangle ACD. So let's take ratio of these two triangles. Area of triangle APD upon area of triangle ACD is equal to, now for APD, DM is the height and AD is the base. So AD into DM. See this. DM is the height and AD is the base. Similarly, for ACD, again AD is the height and DM is the base. So AD into DM, and as the numerator and denominator are same, so final answer is 1. So this is another pair, and so at last we can write area of triangle APD is equal to area of triangle ACD. So in this question they are asking two pairs only, so I am giving two pairs. There are few more pairs are available which are having equal areas. So this is homework for you. You can solve by yourself. Example 4. In adjoining figure, in triangle ABC, point D is on side AC. If AC is equal to 16, DC is equal to 9, and BP is perpendicular to AC, then find the following ratios. First ratio, area of triangle ABD upon area of triangle ABC. From the figure, it is observed that for triangle ABD, we have AD as a base and BP as a height. And for triangle ABC, we have AC as a base and BP as a height. So let's write it. First, area of triangle ABD upon area of triangle ABC is equal to AD into BP upon AC into BP. So this will get cancelled and we get AD upon AC, which is equal to AD. Now we don't have AD, but we have AC. So let's find AD. AD is equal to what? So we have an equation from the figure. AC is equal to AD plus DC, and AC is 60, AD we have to find, and DC is 9. So AD will be 16 minus 9 is equal to 7. So we got AD as a 7 and AC is 16. So this is the answer in the second step. area of triangle BDC upon area of triangle ABC. In triangle BDC, DC is the base and BP is the height. And for ABC, AC is the base and BP is the height. So let's write it. For BDC, DC into BP upon for ABC, AC into BP. So BP get cancelled and we have finally DC upon AC. Now we know DC is 9 and AC is 16. So 9 upon 16 is the answer for second ratio. In third ratio, area of triangle ABD upon area of triangle BDC. We already derived all these ratios, so we can directly write ABD is from here. It is AD into BP, or you can draw see from diagram also. So AD into BP upon BDC is DC into BP. Again, BP get cancelled, and we left with AD upon DC, which is equal to 7 by 9. So in all these three ratios, it is observed that both the triangles will have equal height but distinct base. So for all these three areas, triangles having equal heights. This is the condition one that we already discussed in the previous module. That's it.